Humans have always been determined to explore the hidden mysteries of nature. The thirst for exploring the world and beyond will never quench. That same thirst has taken humans to the moon, robots to Mars, and beyond. Who would have ever fathomed that humans would leave this planet to explore galaxies and beyond? Today, we see how much humans have accomplished. Just to relate the distance, the moon is just 384,400 kilometers away. In a dark, cold, vacant neighborhood near the very edge of our solar system, the Voyager 1 spacecraft is set to break another record and become the space probe that has traveled farthest from home. On February 17, 1998, Voyager 1 was launched more than 2 decades ago. It'll cruise beyond the Pioneer 10 spacecraft and become the most distant created object in space at 10.4 billion kilometers. The Voyager probes use the radioisotope thermoelectric generators. They rely on the natural decay of plutonium to generate heat. With no moving parts, radioisotope thermoelectric generators are not nuclear reactors and can only generate a few hundred watts of power. But as ambitions for missions deeper in our solar systems grow, much larger spaceships propelled by more powerful nuclear generators are back on the agenda. Today, companies like NASA and SpaceX are on a mission to explore different planets. Their main focus surely is the Red Planet, on which they have sent robots to look for any signs of life, water, and to monitor its environment for human settlement. Humanity is poised to embark on a new age of space travel to Mars. As nuclear power and related technologies advance, the interplanetary missions would be faster, more efficient, and economical. The tech giant SpaceX is on a mission to create a human colony on Mars. Elon Musk, the CEO of the company, tweeted, "I'd like to die on Mars, just not on impact." Elon Musk has accomplished anything a man can think of. But the main problem faced by giant space companies like NASA and SpaceX is the ability to cover long distances in lesser time. As of now, it takes almost 6 months to reach the Red Planet. The current Starship of SpaceX can carry a lot of cargo, but the distance-reducing ability is not that efficient. Spending almost 6 months in transit comes with a lot of risks. Astronauts will be faced with hazardous radiation, with long-term health problems such as cancer and organ dysfunction. The spaceships do carry a shielding mechanism, which is very heavy. The longer the voyage, the more shielding is required. So, the most efficient way to cater to all these risks is to travel faster. As of now, there is no planned human mission to Mars, but even exploration missions are required to reach their destinations faster. For example, it took Voyager 2 12 years to reach Saturn. This pushed back the research and exploration of different planets by a decade. When in space, 3 factors are indispensable: thrust, mass efficiency, which is how much thrust a given amount of fuel can produce, and energy density. So, how is a nuclear spaceship powered? The induction of nuclear technology in spacecrafts dates back to the 1950s. NASA began exploring the nuclear thermal propulsion systems, but due to several setbacks, this technology cannot reach its potential. The conventional rockets use chemical propellants to create the required thrust. Fuel-burning rockets and solar-powered electric propulsion systems are also used. Chemical propulsion is the most widely used, but comes with a major drawback. It must carry a lot of fuel for the voyage, hence decreasing the ability to cover large distances. Solar-powered propulsion systems are efficient, but the thrust produced is very minimal. An example of solar-powered systems is that they can only produce thrust to drive an automobile from 0 to 60 miles per hour in about 2.5 hours. We don't really want to head to Mars in a spaceship with such thrust-producing capabilities. Elon Musk finally created an alternative. That is nuclear-powered propulsion, also known as nuclear thermal propulsion. It has the potential to dramatically reduce travel times to distant destinations while increasing launch flexibility and making spaceflight safer for astronauts. The uranium fuel offers incredible energy density. Even a small amount of uranium can replace thousands of gallons of fuel. How will the nuclear thermal propulsion system work? What are the advantages and hazards? Let's dive deep into the details. Rockets lifting off from Earth will depend on chemical fuels for the foreseeable future. However, once in orbit, nuclear engines could take over and provide propulsion to accelerate spacecraft through space. In nuclear thermal propulsion, a nuclear fission reactor heats up a liquid propellant like hydrogen. The heat converts the liquid into a gas, which expands through a nozzle to provide thrust and propel a spacecraft. Reduced time in space also reduces astronauts' exposure to cosmic radiation. The spacecraft would require less fuel to reach space and would significantly reduce trip times. This would cut the travel time to Mars by 25% compared to traditional chemical propellant rockets. Another alternative is nuclear electric propulsion. In this system, thermal energy from nuclear reactors is converted into electrical energy to produce the required thrust. This eliminates the need to store propellants. The thrust produced is lower but continuous, and the fuel efficiency is far greater. It'll potentially reduce transit time by 60% to Mars compared to traditional chemical rockets. Nuclear reactors would be great for extraterrestrial surface power for astronauts. It would provide explorers with a reliable source of surface power for extended exploration missions. The nuclear reactor can supply an electric power in the range of tens of kilowatts for a period of 1 to a few decades. Besides the thrust, the spacecraft would require an infinite amount of electric power to maintain life support systems, communications, and other hardware. Fission surface power reactor designs are micro-reactors that could provide the required power for a long time. As the distance to Mars is very large, having enough fuel to reach, return, or abort the mission to Mars is very necessary. Most of a chemical rocket's fuel is used at the commencement of the mission. This is because the engine requires large amounts of fuel to break free from Earth's gravity. That means that a Mars-bound spaceship will not have enough fuel to return to Earth if the crew needs to abort the mission. On a nuclear-powered spaceship, astronauts would not have to worry about the fuel, even after months into the journey. The nuclear-powered spaceship would still have to carry a lot of fuel for landing on Earth. The spaceship would have a greater dry mass from traditional chemical-powered rockets. The main question which pops up in our minds when talking about a nuclear spaceship is whether it is safe. Even a nuclear spaceship would always contain liquid propellants between the engine and the cockpit. This will mitigate the effects of radiation. Apart from that, the distance from the engine and crew compartment will also decrease the effect of radiation significantly. The nuclear reactor itself has a buffer shield to absorb radioactive radiation. Apart from that, the fuel inside the reactor will also be sealed and protected. But, as the spaceship will be launched from Earth, how would the radiation be contained during takeoff? SpaceX has already devised a very smart solution. In a tweet regarding nuclear-powered spaceships, Elon Musk wrote, "To be clear, good for in-space transit but not recommended for Earth orbit." So, the spaceship will use chemical propellants until it has reached the orbit. After that, the nuclear engines will kick off. In case of a disaster, the pieces will not land on Earth for tens of thousands of years. By that time, the radioactive material would be non-hazardous. Nuclear spaceships are very promising, but the space agencies would still need to work hard to improve flaws in this system. SpaceX still hasn't decided to fully fund on this advancement, as the nuclear spaceships could not be reusable because of the potential risks. But NASA plans to put a nuclear-powered spacecraft in orbit by 2026. NASA also plans to equip a crewed chemical rocket with enough fuel to get to Mars. The fuel for the return trip would either have to be sent to the Red Planet in advance or created using resources on Mars. A moon mission with nuclear-powered spaceships would be a good reconnoitering mission for the space agencies. This will help agencies to check the efficiency of the system before launching it to Mars. Building self-sustaining conditions on the moon with nuclear energy and monitoring the human conditions is very important before the years-long journey to Mars. If a viable fusion reactor can be developed, we could see a nuclear-powered ship heading out for our immediate cosmic neighborhood to the stars and planets within this century.